Hello? Here, we are going to solve for the real line integral of the given function. We have here the integral of x dx plus y dy along your path C, which is a straight line from 0, 0 to 2 and 1. Take note, this is on the real line integral, which is identified this manner. The integral of p of x dx plus your q x of y dy along your path C is identified as the integral of, you have here p of x of t. Okay, we are parameterizing that in terms of t times the first derivative of your x of t plus your q of x of t y of t times the derivative of your y of t with respect to dt, okay, along a to b. Now, notice here that our given path is a straight line. Don't forget the proper parameters for having x of t and y of t for straight line between 2 points. Okay, so we have these items here. If I may, I'm gonna write it somewhere here. Okay, for your x of t, this is the one indicated in one of our videos. It's actually x sub 1 plus t times the difference of x sub 2 and x sub 1. For your y of t is y sub 1 plus t times y sub 2 minus y sub 1. Okay, in this case, our points are actually identified as 0, 0. This would be your x sub 1 and y sub 1. And for your 2 and 1 will be your x sub 2 and y sub 2. Now, as for the A and B, take note that if we have a straight line, okay, the parameters of A and B are the endpoints of your t, which is actually equal to 0 and 1. Meaning A is 0 and B is 1. So we just need to identify first x of t and y of t, so we can identify their first derivatives, okay, so that we can look into this later on as a whole. So let's start with x of t. So your x sub 1 is 0 plus t, take out of these items here, okay, along this red box here. So your x sub 2 is 2 minus 0. So you have here 0 plus 2t, this should be 2 minus 0, which would give us 2t. This is your x of t. For your y of t, the parameter of that, we have here y sub 1 is 0 plus you will have here t times y sub 2 is 1 minus 0, which gives us 0 plus t, which is t. Okay, so we now have these functions here, but of course we're going to plug that in on how do we define our p of xy. Actually, our p of xy is x, this one here, and our q of xy is just y as indicated here. That would mean for our function here, we don't need the y of y sub t, y of t, because it's only x, and for the second here, we don't need the x of t because it's only y. We'll have it later. Okay, we just need to finish this because what we need more is your first derivatives. Okay, so if your x of t is 2t, with respect to t, its first derivative is 2, and your y prime of t is actually t, so its first derivative is 1. Now all of them already identified. Let's try to provide now the final, the next form. Take note again, this is its equivalent form here. So you have, let me rewrite that again here. Hopefully I could finish it faster. Y of t times x prime of t plus q of x of t y of t times y prime of t dt. A to b. Using all details for your p, okay, so it's the a is actually 0 and 1, so you have here 0 to 1. Your p is actually just x, so we're going to use only x of t. So that's actually 2t times the derivative of your x of t is actually 2 plus your q is only y, so we're going to use only the y of t, which is just t, times the derivative of your y prime is actually 1. Right? This is under dt. So to continue, 0 and 1, this is equivalent to 4t plus t dt, 0 to 1, so you have 5t dt. By multiple, constant multiple, move the constant 5, integral of t dt 0 to 1. We know that the integral of t dt is actually t squared over 2. So you have here 5 times t squared over 2 from 0 to 1. So finalizing the answer here, so 5, 1 squared over 2 minus 5, 0 squared over 2. This is actually 0. So it gives us the answer of 5 times 1/2, 5 halves. This is the value of the real line integral of the given integral here, x dx, where x plus y dy along a straight line from 0, 0 to 2, 1, using the forms for the parameterization of your x and y, the identification of your boundaries a and b, and of course your first derivatives of your x and y, then proper substitution and all operations here yielded 5 halves. Thank you very much for watching.